All right, this problem usually at first looks pretty confusing for students. They see a complex fraction, but then they also see variables raised to the negative power, which we know is now going to produce more fractions, and it might just get overwhelming and you'd be like, I don't know. And what I want you to do is just kind of look at this, write down the things that you know, and just take small steps forward with the things that you are familiar with, and just try to make a game plan to see if you can actually simplify this complex fraction. So the one thing that I immediately see whenever I see negative powers, like go back to your Algebra 1 days, right? We know that x to the negative n is equal to a 1 over an x to the n, right? Where n can represent any number. So the first thing I recognize in this case is I have x to the negative second. Like, why even have the problem written like that? Is this just our teacher or the textbook trying to confuse us? Like, let's just go ahead and rewrite these as a rational expression. This is 1 over x. OK, so now you can see that we have a fraction, we have a numerator and the denominator, we have fractions in the numerator, fractions in the denominator, and then to add on to this problem, I have another fraction in the denominator. Now that is going to be kind of like too much for me to handle, right? I think this is a great problem to see students kind of problem solve. Like, what would you do? Let's say I never gave you a problem like this, and I say, all right, now just go ahead and solve it. Go off of what you know to be able to figure out a problem, because most of my students have only up to this point would have worked with problems that had fractions in the numerator, fractions in the denominator, and that's it. So what can we do? Well, there's a couple things we can do. One thing that I want you to recognize is I need to get this x off the denominator, right? I have to get rid of that x off the denominator. So one thing I know, if I want to get rid of an x, if I multiply it by an x, they're going to divide out. That's going to equal a 1. Right? The other thing I know is if I have a 2/3 and I multiply it by an x over an x, no matter what my number, whatever my value is for x, it's still going to be equivalent, right? Because as long as I'm multiplying the same thing on the top and the bottom, I'm producing equivalent fractions. So if I want to get rid of this x, I know I can multiply it by an x, right? But whatever I do in this denominator, I have to make sure I do in this numerator. And again, I'm focused over here. The other thing that's also important is recognize that this whole denominator has 2 terms in it. It's not just 1 over x. It's 3 minus 1 over x. So therefore, I need to multiply the x times both terms. All right, so that's kind of super important to make sure you understand and see. Now let's go ahead and rewrite this problem with me distributing that x to my numerator and denominator. And then we'll have something I think is going to be a little bit easier for us to work with. There you go. OK, so now we have multiple fractions. We have 4 fractions, 2 in our numerator, 2 in our denominator. But now what we need to do is get rid of them. So kind of like here, we knew that if I multiply by x, my x is divided out, right? So that was good. In this case, now we got to see, all right, well, what is going to be the smallest expression that x squared, 3 minus x, and x all divide into? Now, we don't need to worry about repetitive. We don't need to multiply here to get x to the 4th power, right? We just need the smallest term that all of those are going to divide into. Well, since x divides into x squared, and x squared also divides into x squared, I know I can multiply here everything by x squared, and that would get rid of my x's and my x squared. And then obviously I have this binomial here, which is a 3x minus 1, so I need to multiply that as well. All right, so now I don't have enough room, but for the sake of time, what I'm going to do is you need to distribute this, just like we did over here in the top and bottom, right? You need to be able to multiply this x squared times 3x minus 1 times everything in the numerator as well as in the denominator. So I'm just going to write that out. Sometimes I use like a little distributive property here, but yeah, you need to produce an equivalent fraction to simplify. All right, so now let's go ahead and simplify this to see what we're going to get. Here, my x squareds are going to divide out. That's just going to leave me with a 5 times a 3x minus 1. Over here, my 1x will divide out, right? So that's going to leave me with a x times x minus 1 times a 3x minus 1 all over. Here, my 3x minus 1's divide out. So that's going to leave me with a x squared times 4x. And then plus here, again, another x will divide out. So that'd be a 6 times x times a 3x minus 1. All right, so I have some distributive property over here I can apply. Over here, I'm going to use distributive property or FOIL, whatever, but I'll do this in my head. So this is going to be a 3x squared. Let's see, that's going to give me a negative 3x. And then this is going to give me a negative x. I don't remember that. Was that my problem? That should be a positive 2x. X plus 1. I thought I had an x plus 1. Did I rewrite that problem wrong? Oh, I did rewrite the problem wrong. That's supposed to be an x plus 1. I thought I said something. OK, so that's a plus 1. So that's going to be a 3x minus x, so it's going to be plus a 2x minus 1, and that's still going to be multiplied by x. So we're going to have to distribute that again. So this will give me a negative 3x cubed. Let's see, minus a 2x. I'm kind of doing my work upwards, so it's just kind of weird. I don't think I remember ever doing that before like that. And then over here, I can distribute that, and that will give me a 18x squared minus a 6x. And then this will be a 15x minus 5. And this would give me a 4x cubed. All right, so I'm just kind of doing the math, multiplying, talking my way through it. And now let's just go ahead and rewrite everything. Hopefully it's going to make a little bit of sense. So I have a negative 3x cubed. This is definitely supposed to be squared. And so I have a negative 2x squared. Then that's definitely supposed to be an x. Man, I'm like striking out here. So that's going to be a plus a 16x, and then minus a 5. And then down below over here, I have that's a positive. So that's a 4x cubed plus an 18x squared minus a 6x. OK, so now that's at least been simplified. But if you want to go a little bit further down, you could factor out a negative in the numerator. Maybe try to see if you could further factor that down. And then in the denominator, you could definitely factor out an x and then see if you could further factor that down as well. But for at least simplifying, getting rid of a complex fraction, we'll call this good.